Hello there, welcome to video number 203. This one is on scatter graphs. The keywords I've got for you are correlation, relationship, LOBF, which stands for line of best fit, estimate, and outlier. Now the correlation is to do with the connection between the two variables. Okay, I've mentioned what variables are before, two things that change. So on the x-axis you'll have one variable, on the y-axis you'll have another variable. This is called bivariate data. Which means two types of data represented in one graph. And the correlation is the connection between those two things, which we can describe as either being positive, negative, or none, no correlation. And a positive correlation will have very visible points that are going up in a particular direction. Negative correlation will be going down, and no correlation, points will just be all over the place. Okay, so that's in connection to the line of best fit that you can draw. Relationship is slightly different to the correlation in that it's basically what's happening in one thing that's affecting the other thing, or seemingly affecting the other thing. It's not always it's important to understand that one thing isn't necessarily the cause for the other thing happening. The graphs don't show us that. They do show us a relationship though. Alright, so it's a very slightly different thing. It's quite nuanced, it's quite specific. LOBF, the line of best fit, is as what it sounds like. It's the line that fits best with all the points. I'll show you how to do one of those in a bit. Estimate means to work out a rough answer to, and outlier is a data point that doesn't fit with the rest of the trend. It'll be obviously outside of things. Okay, so the method stage, you will need to plot some missing points on a graph. This is one of the things you're going to need to do. Draw a line of best fit, so make sure you've got about the same number of points either side of the line that you draw. Make some estimates using the line of best fit. I can't say fit for some reason. Draw from a given point that you are given in the particular question. Hit the line of best fit, find the corresponding value on the other axes, and then describe the correlation and or relationship. Could be positive, negative, or no correlation. Relationship is a connection between two variables described in words. Okay, so question number 1A, plot the points from the table into the scatter graph and draw a line of best fit. So this is, you can see that on the x-axis we've got the maths score for a test and the English score on the y-axis, and we can plot those 2 points. So this data point is one person's results for both subjects. Okay, so we're going across to 60 and up to 70. So 70 there. I'm just going to do it with a little dot. It's just easier to do it with dots on this. Do a little cross with a nice sharp pencil. 35, 40. So 35 on here is there, and 40 is there. Be as accurate as you can be. 195. So 100 and then 95 will be. If that's 90, that's 95. Halfway. 55 and 40, so it's 50, 55, up to 40. You can see we're starting to collect some points together here. 75 and 75, got 75 on both tests, so 70 there, 75, and 70 there, 75. Okay, 20, 30, 20 here, and 30 here. 45, 30. 45 is there, 30 there, and then 80, 85, 80 to 85, might be a bit of the video you want to fast forward, is there. Okay, so what I've done is got all of those points in there, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. It's worth having a little check that you make sure you've got the right amount of points plotted. It says draw a line of best fit. I don't think I've got a tool to draw a ruler with here through those points, because I think those points will disappear if I do that. So I'm just going to draw it by hand, but what you should do is use a ruler and a pencil to draw a line of best fit. Now 1, 2, 3, 4 there, 1, 2, 3, 4. I could draw it kind of sort of going there, and this is done by eye. Okay, you do this by eye. There's no points there that kind of don't fit this trend. Okay, so I'm going to draw a line of best fit, sort of like looks like that. The temptation for some people is to go from 0 and draw it all the way through. Don't do that. Okay, and another temptation is to join the bottom point to the top point. Don't do that. Okay, try and get through or as close to as many of the points as you possibly can. All right, so 1, 2, 3, 4 on this side, 1, 2, 3, 4 on that side. Maybe I could draw it a little bit closer there, another line there. So my line of best fit will be different to your line of best fit and everybody else's line of best fit. But we're still all going to be correct because we're allowed to be within a specific range in exam papers. Okay, as long as we've done it logically, we'll get away with it. Describe the correlation, or you can see as one point goes up, as one score goes up, so does the other one. Okay, for most people. So that is a positive correlation. That's all you need to say. Okay, now question number 2, we have to estimate the score that a student may get if they score 35% on the English test, and then estimate the score a student may get if they score 60% on the maths test. So it's a similar sort of thing, but this time we've got the points that are plotted, and that's really how you should plot them with the X's and draw the line of best fit. You can see my line of best fit actually, it's the same graph, so if we look at both of those, very, very similar line of best fits, which is all good. What I'm going to do is I am going to try and zoom in on this one, I think, because then I can get a line and draw it in nicely. So I'll tell you what I'll do, so I'm out of the way of that graph, because I think I'll cover it over if I do that. Hold on. Move myself over there, and then I'll do the zooming in. So in we go. Have a look at this. Get the line. So from 35% on the English test, so 30 is there, 35 is there. Okay, we go across and we draw a line that hits this line here. Okay, and we draw a line that goes down. All right, so down, across and down, and we're going to see that that is 30%. Just remember that this at the moment, because I can't use the pen tool on here, doesn't work very well. I could try, but it's not a 3, is it? 30. There we go. So 30% there. And then the line, estimating the score a student may get if they score 60% on the maths. So on the maths axes, go to 60%, do the same thing, but just draw a line up and then across. See what that hits. So that looks to be about 62%. So we'd write down 62%. And I'll try and do that again. It won't look great, but oh, it's a bit better. That's not a better 2 though, is it? There you go, 62%. So it's a very simple thing to do. Once you've drawn that line of best fit on, it's a line that goes across and down or up and across. Okay, depending upon what the question's asking you. Both examples are covered there. Okay, zooming out of that one, and we will get rid of that horrible ratty looking stuff and just fill it in there with a 30% and 62%. Okay, now the third question here, the scatter graph shows the value of 15 sports cars against the age. We have to describe the correlation. So in this particular example, it might be tempting to say, well, it's negative and then positive, but we don't say that. What we'd say here is that it's got no correlation. All right, there is no correlation because all the points are in sort of random or random looking order. Okay, now the relationship is slightly different. What we can say here, there is a relationship, and this is one of those strange questions where the relationship is different to the correlation. Most of the time it is the same. All right, what happens is the cars, newer cars are more expensive, then get less expensive or depreciate in value, and then they start to appreciate again. Okay, so that is our relationship. That is what that graph is showing us. Okay, so cars depreciate in value, and after some years, maybe 30 years, we could even state that, we don't have to, after some time start to appreciate again. Okay, and that is what the relationship is, and that is a nice question that demonstrates the difference between those things. Okay. Would it be possible to estimate the value of a car that is 100 years old? We need to explain the answer. So the reason, what we say here is no, it wouldn't be possible. It's possible to do it, but it would be what we call extrapolating results, which means taking an idea of something from outside the range of data that's been collected. We don't have to use the word extrapolate because it's a fancy word. We don't actually have to use it. So no. We can just say it's outside. So 100 years is outside the range of data collected. And that would be an acceptable thing to say for that question. Okay, lovely. That's scatter graphs for you covered. I don't think there's much more that you might be asked on that. There might be some fancier questions every now and again. Oh yeah, there's one more thing actually I didn't mention, and I've just noticed it in question number 2. I'm not going to go back and film the whole thing again, right? That piece of data there, all right, I don't know if you notice it, it's a blue cross. That is what we'd refer to as an outlier. It doesn't fit the trend of the rest of the data. So the person that did the maths test there, 20 on the maths test, but did really well, got 90 on the English test. Okay, clearly not someone who's great with the maths, but very, very good with the words and the English. Okay, that's a bit of an outlier. Okay, because it doesn't fit the rest of the trend. I think that covers everything. All right, so I hope you've enjoyed that one. Take care of yourselves, look after one another, like, subscribe, practice the maths. That's the most important thing. Once you've watched these videos, practice. It will make you better. Take care. Bye bye.